Okay, Common Core Standard. Today we're talking about navigation. Today's day is 12/12. Cool. 12/12/17. So, first of all, let's just talk about bearing. There's two ways to talk about bearing. One is using a north or a south start, and the other is doing a full rotation, okay? One is using a north or south start, and the other is doing a full rotation. So let me show you the difference, okay? So, example one, north, 30 degrees east, okay? Okay, watch. So if I'm pointing north, think about this, north, I'm going to rotate 30 degrees towards the east. That's all I'm going to do. So think about it. I'm looking north, and I'll rotate 30 degrees to the east, so my bearing in this case would be, I'm pointing north, so I put my protractor, I zero it out, so I zeroed out my protractor, and I just rotate towards the east 30 degrees. Okay, so I'd be heading in, for a boat or an airplane, I'd be heading in that direction. That's north, look north, and then rotate 30 degrees towards the east. Example 2 starts at south. So we're going to look south. So we're looking south, and then we rotate towards the west, 25 degrees towards the west. See, we're looking south, and we rotate towards the west. So I'm going to zero myself out at south. So I'm going to zero out at south, and south is 0 there. And then I'm going to rotate 25 degrees towards the west. 10, 20, 25 degrees towards the west. That would be which way? Our boat or airplane. So I'm looking south, and I rotate 25 degrees towards the west. Okay. So that means my boat or my airplane or my jet ski or whatever I happen to be in is going that direction. And then the second way to navigate is to just use a full 360 degree rotation. So north is up at 0, and we're going to rotate 300 degrees, which means we're going to go all the way around like this, right? So a full 300 degree rotation, I'm going to zero it out, and I'm going to go, 90, 180, there's 270, there's 300 degrees. 300 degrees is actually on my protractor, so I'm going all the way around to 300 degrees, which puts me right there, okay? All the way around 300 degrees. So if I were a boat and I had to turn my boat all the way around to a bearing of 300 degrees, and most compasses do it in full 360 degrees. So if you've ever been on a boat, it's kind of cool. You got this big compass sitting in the front, and it does spin around a full 360 degrees. If you get a heading of 300 degrees, you'd be heading kind of a little bit like northwest, wouldn't you? Now, if that's the case, I know this would be 30 degrees, and that would be 60 degrees, right? So that's where you'd be heading on a bearing like that, okay? Now, example 4. You will have a problem like this in the quiz. It's not hard. We just have to draw it correctly, okay? So for me, before I even draw it, I got to get an idea of where I'm heading, because sometimes if I start drawing in the wrong place, you know what happens? I run off my paper. That's a bummer. I don't want to run off my paper, okay? So I kind of try and do a little bit of, drawing it out with my finger and then trying to figure out which way I'm going. So 2 ships leave port at the same time. Ship A travels at 8 knots on a bearing of north 35 east. So that's kind of north 35 east. That's going that way, right? Ship B travels 6 knots on a bearing of south 10. So it's going down like here. So I'm thinking that one ship's going up like this, the other's going down like this. So I think when I draw, I might put my port right there. So I have room. So if I put port, I'll put P that for port right there. Then I know one boat's going that way, the other boat's going that way, and I think it should fit on my paper, right? So I need a compass. So I like to put on what I call the compass rose, okay? So I need a compass. So I'm going to draw in what I call the compass rose, okay? I just like to draw in the compass rose. The compass rose gives me my north, east, south, and west, okay? So I like to draw that in, and that gives me a place to start, right? So I put in my compass rose, do my north, east, south, and west, and then what I'm going to do is try to figure out where am I going? Well, I'm going north and 35 degrees towards the east. So, all right, let's point north. Let's point north, and let's go 35 degrees, 10, 20, 35 degrees towards the east. All right, so I'm going north, and I'll go 35. I'll rotate 35 degrees toward the east. Now that's going to be 6 knots, so I'm going to draw it 6 centimeters, okay? You might go up, well, that's not too bad. So I'm going to draw it 6 centimeters, okay? Draw it 6 centimeters. Okay, 35 degrees here. And that's 6. And that's ship A, okay? How am I doing, all right? Let me slow down for a second, let you catch up. Okay, so my boat's heading north 35 degrees towards the east. I went north, rotated 35 degrees toward the east, drew it 6 centimeters, okay? Ship B, though, is traveling 6 knots at a bearing of south 10. So I'm going to look south, and I'm going to rotate 10 degrees towards the east, okay? I'm going south, and 10 degrees towards the east, okay? So again, I'm going to use my protractor. And then from port, I'm looking at 0 degrees. I'm going to rotate 10 degrees towards the east. So just 0 to 10, okay? 0 to 10 right there, okay? 6 knots. I'm going to draw it. Oh, I did make a mistake. You guys have to catch me when I make mistakes. That was supposed to be 8 knots. I did. That's supposed to be 8 knots. That's okay. It's way up there. Change that to 8. There's A way up there. Man, how did I do that? This one's 6. And there's B. There's my 10 degrees, okay? Okay, so the first thing I'd like to know is, I'd like to know the angle in between. So the first thing I'd like to know is this angle there, okay? That's the first thing. If I can figure out that angle, then I'm pretty happy. That should be pretty easy to find, okay? I know that this angle here is 55 degrees out of 90, right? And I know this angle here is 80 degrees, right, out of 90, because between east and south it's a 90-degree angle. Between north and east is 90. So hopefully all of this makes sense. Hopefully this is just common sense. Does that make sense? Simon's just sitting there going, I got this. You can see it already. You're just like, you're chilling because you got this, don't you? So then the angle between has to be a 135-degree angle, right? And I need that. I need the angle between the two boats, okay? Now, after 3 hours. So what I'm going to do is let them travel for 3 hours. I could draw the darn thing 3 times as long, but that'd be silly, right? I could draw this 3 times, so that'd be silly. All I'm going to do is just going to multiply the lengths by 3 and say it's 3 times as long. So then this is really going to be times 3 or 24, times it by 3, and that's 18, okay? So if I go for 3 hours, it goes from 8 out to 24. If it goes for 3 hours, it goes from 6 out to 18, okay? Now, how far apart are they? Well, that's got to be this thing right here, okay? Call that D. Yeah, Simon.
Is it not a mile an hour?
It's pretty close to a mile an hour. Knots are a little bit longer, and it has to do, you know where knots come from? It has to do with lines of latitude and longitude, and so you get a degree, and however many miles a degree is, they divide that into minutes, right? So you get 60 minutes. You divide those minutes into 60s, and those are seconds. 1 second is a nautical mile. Go back to old times. Say it's really kind of a fun little history. So you used to navigate like hundreds of years ago without all this fancy stuff, and they would take a rope and it'd have knots tied to it, and they'd throw it overboard. Okay, and the faster you went, the more knots it would show, because it would float up. Does that make sense? But as the slower you went, the more the rope would sink, and you'd see less knots. But that was how they'd use a sextant to get the angle, and they'd count the knots to get a speed, and that's how they navigated. So that's where knots comes from. But it technically, knot is 1 second from a minute to a degree on a lines of latitude or lines of longitude. Okay, anyway, let's find D. So what do I have? I do have side. What do I have? I have side, angle, side, don't I? If I have side, angle, side, I can use the log cosines to solve this. So I'm going to set up D squared equals 18 squared plus 24 squared minus 2 times 18 times 24 times the cosine of 135, right? And I'm just going to let my calculator do the work for me. Okay, this is not that hard, is it? You guys agree? Hoping it's not that hard for you. 18 squared plus 24 squared minus 2 times 18 times 24 times the cosine of 135. Okay, square root that answer, right? Square root that answer, and I get about 38.9 about. So the distance is about 38.9 degrees. Okay, I'm going to stop it there.
Wouldn't it not be degrees if it's a digit?
Oh my goodness, you are right. It is knots. I got to change it to knots.